Okay, I hope everyone can hear me. If not, Sarah will no doubt interject very quickly. Right, today's FAQ Friday is a little bit different to the normal FAQ Fridays. We're going to try and show you a little bit. Well, it's going to be agenda based, and we're going to try and show you a few of the features that are upcoming in ICS Telecom and Warfare. Just a few of the features, not all of them. The list changes every day, but these are the ones that we've got some obvious evidence of at the moment, and that the tool can actually work, or that we're using will actually display. So that's what we're going to do to start with, and then we're going to go over to. It's actually quite simple. I remember when I first thought, how the hell do I display drive test data in telecom? It seemed almost impossible to me. It looked very complex, but it's actually relatively simple. A few other people might also discover quite how simple it is. And we're currently working with a drive testing tool called Aries, which we're using primarily for a mobile phone coverage survey, and we'll show you a little bit about that, and then I'll show you how to import that data into telecom for further manipulation. Although Aries itself can do quite a good job of analysing the data, and all we'll be doing with telecom is displaying it, and I'll explain what we can probably get on with after that, and then. This is an update, exporting coverage as a shapefile, an ESRI shapefile, and then displaying it in a GIS tool. We're going to use QGIS, which is an open source GIS tool, free to use. It's sort of very similar to ArcGIS, if any of you use that. But the good thing about it is that you can download it and use it, and you don't have to pay anybody, although they would appreciate donations, obviously. And primarily because there are some gotchas with shapefiles that you need to be aware of. Right, so what we'll do is we'll start with the new features in telecom. Now, I'm going to warn you that I don't know very much about some of these features, primarily because they're new, and there's no documentation on them, and the only people that really know how or why these functions are required are the programmers and the people that have paid for these features to be added, or have asked for these features to be added. So if you're, for instance, we'll go into broadcasting to start with. If you're a broadcaster, you might know what some of these are. I don't necessarily know, but I will go through them anyway, and we'll go with that. So for doing a single frequency network, this is the sort of thing you would do with a DAB, digital audio broadcasting network. There are now options for, or there is now a location probability map, and that's the modulation system being used, and there's a tracking of facility. Now, in my days, single frequency network, everything on the single frequency network was correlated. So you were on the same frequency, all the transmitters transmitted the same information at the same time, synchronized. And that was so much easier to make it all work. And what these tools do, and this tool here, allow you to plan slightly less correlated or uncorrelated DAB transmitters on the same frequency, local opt-outs, that sort of thing. Far too complex for me. I last looked at DAB when it was being introduced about 25-30 years ago, and apart from listening to it, I don't do any DAB planning, so a lot of this stuff is out of my comfort zone. But you can now do, for instance, you can define a C2I formula, and there's a little dialog box that will pop up and allow you to define that. The same for this. You can deal with the equalization interval for the European Broadcasting Union method, which wasn't defined when I last worked on this. And then there's coordination methods, planning methods, a dual model for location probability calculations. Again, that allows you, I think, to look at a position and what kind of service it will get in two ways. And there are 3 new signal types have been added for this for broadcasting services, and there are also some station import formats. I think there'll be TVD files or something like that, but again, not an area that we have any documentation on, but I would guess that's what it is. For point-to-point links, now there's a transport option, and this is the documentation that we've got that says it allows each transmitter end the transport bit rate according to the station's bit rate at the same location. I'm not absolutely sure what that means, but if you look within Telecom, you go to the microwave list, there's a transport button. Now this microwave link is, I've just chucked it on here, so it doesn't have any bit rate set or anything like that, and I suspect that probably accounts for why we're going to get what we get. If you click on transport, it pops up and tells you the bit rate, and that transport rate I believe to be, Nick might know, but I believe that to be the rate or the over the link rate of the data that's being passed. That's the keying rate of the link, 256 kilobits per second, and that's what's being transported. So at the moment, because I haven't set up any kind of FEC or anything like that, I should think that's probably why it's saying 0. But it may also be that the feature isn't entirely finished on my copy of Telecom. Where were we? I need to just go back to my slide. There we are. Satellites, again, there's a new satellite object dialog box. Oh, well, my brain has made me ignore this one. The point refractivity gradient values have been modified, and the link objectives or reliability objectives have been reduced from 99.99 to 99.98, although I think some of the documentation actually says 98%, which to me is a kind of reliability objective you'd expect from a plastic 5 gig consumer point-to-point link for Wi-Fi. But anyway, the end result of this refractivity gradient, and if I go to here, microwave link path budget, there's the point refractivity gradient. Now if I update this for the location of this little link here, it's -128.76. In previous versions of Telecom, using previous versions of the maps, it was an interpolation again, and that would have been around 200, 250, 300, something like that, depending on the location. That's causing a bit of consternation. We believe we've got it right. But it is causing some consternation because that and the reliability to achieve, which I've set here for 99.99%, does result in some changes in the overall performance calculations. The link will work the same way as it has done before, but the results you get from the calculations might be more accurate now. That's probably the best way to put it. But yes, that's causing a lot of confusion. It isn't the level of the map. It is a point refractivity gradient value, and there's new maps for that in 453. And they're spreadsheets, so you can actually go into them and look at them You work out your lat long, and then that tells you where in another spreadsheet tab you need to go to pick up the levels for various heights, and then our tool will interpolate between them. So you can actually manually go and check if you check the appendices to recommendation 453. There's spreadsheets there you can actually open up and look into to make sure you're getting the right levels. There's a new satellite object dialog box. That I'm not sure if I've actually got that in my copy of Telecom, to be honest. I couldn't find it, but there is one, or it's coming. We'll find out more about that as it comes along. As I say, this is all bleeding edge development stuff. Land mobile, there is a new signal type added, MPT 1327. Those of you who know MPT 1327 were probably not born before it was implemented. I was already a young man. It was about 25 years, maybe 30 years since 1327 arrived. It's just a signal type. There's no difference between that and a generic station as yet, but it is available in Telecom now, so you can find a station, and its signal type will be MPT 1327. There you are. Type 109. There are 109 types. It's the last one on the list, and it doesn't actually make a lot of difference in these figures, although some of these levels may have changed. Anyway, that's that. For modifications to the actual user interface, there is now a new C2I interference box, which is great because the old one was utterly confusing. And if we go into here, you can now go to coverage, network interference. If you go to C2I mode, basically there's no difference in what's in here. It's just been laid out a little bit more clearly. So you get the C2I maps in the same area, and there's some spaces added and whatever. My mind map always puts me into this area for map on best server, and it's still roughly where I always want it to be. That's the one I would normally be using. I'd be setting a threshold and worrying about distances and that sort of thing. So yeah, that's it's much clearer than it used to be, but there's no difference actually in the content as far as I can see. But then again, the previous one was so cluttered, it was very difficult to tell what was going on anyway. There's a new Earth radius calculator, which you can do from the K factor. Pop back into Telecom again now. File, preferences, model, settings. There must be a faster way of doing that. Here we are, Earth radius. And you can click on that button and you can add your K factor. And it's just 4. And it tells you what the Earth radius is in virtual terms at that point. I'll cancel that just in case I'll get myself into trouble later on. So that's quite useful. There's a standard deviation calculator. I'm not sure if I've actually got that on my tool yet. There's no information as to where it might be. I can't find it. I need to upgrade my copy of Telecom probably. And there are more attributes and a new residential algorithm for the clutter builder. Again, I think that one's too new for my copy of Telecom. I couldn't find it.
Just to keep you updated, for limited customers, that's for UK customers, we will be releasing the next version of ICS Telecom in June. So you'll see a lot of these new features plus more, which we'll be demonstrating in our ICS Telecom Masterclass. So that's a masterclass that we'll be holding in June to coincide with the latest release. For all of the other customers across the group, you've got access to all of these updates at the moment. So you should be able to access that via your portal.
I'm not sure if they're all entirely available yet, because I'm using the portal version as well, or sort of you could call them the nightly builds. It's much more dangerous out there on the bleeding edge, you know. There are some nice new propagation models. There's here F2113, which is an error performance objectives specification. 52614 replaces 52613. 14 uses Delta Bullington. I'm not sure whether 13 was actually in telecom for very long. It was 12 before that, which used Daegu. And I think, in fact, Daegu is still there. Oh, we've got 14 and 11. 11 uses Daegu, and 66 at that. I think 12 used Daegu 94, which it's arguable whether that's actually or whether Delta Bullington's actually as good as Daegu 94. But anyway, that's by the by. A recommendation 530. Again, it's an update. It's propagation, prediction, and path budget document. And then there's the EGLI model. That's now integrated into telecom. It's no longer an add-on DLL. It's not one I would have normally used. It's most of these are for microwave links. There's been a lot of work on microwave link planning recently in telecom. And then there's something that Nick knows all about, the RMS wave height parameter. It now supports variability. It doesn't actually show, well, there's variability there, but there's your wave height parameter, and you can set it for the wind speed, which is about what it is here at the moment. So I'd expect a wave height of about 4 feet, 1.21 meters. So you can set wave height, and I think there's a standard wave height for doing oversea calculations, and it's probably is 10 knots because that's what I had it set for originally. But if you're doing that sort of thing, you'll know these things. That, as far as I can see, covers that side of things. These we'll be dealing with a little bit later on, but no, we'll do it now. We'll We'll follow the flow. The Worldwide Builder, if any of you use Map Server and use Map Server to build coverage map, or to build terrain and clutter maps, the Worldwide Builder database has been withdrawn. That's a quite low resolution worldwide database of height, or terrain height. It's sort of equivalent to 100 or 200 meters depending on where you are on the planet. So most of the time we have better access to map data, and that's available from our Cartographics website. And if anyone needs to know what that is, I can display the link. There's a function called MapQuad that has appeared, and it actually allows you to prefetch, is the term used in web services, all your background images for online mapping. So if I close all this stuff, this map here has been prefetched, so I can just zoom in. This is all online mapping, but it's actually just being picked up off a map cache server on my network here in the office, and it's also on the hard drive. So if it drops off the hard drive, it'll pick it up off the server. So this is probably actually coming off the hard drive. So I can zoom in and out quite happily using this particular map layer, which is the OpenStreetMap topo layer, which I tend to use a lot because it reminds me of the kind of mapping that I'm used to. If you go to something horrible like Bing Roads, this I haven't cached yet, and I have a slow network connection, and you can see here there are areas in this map that will probably paint themselves in at some point or another. I'll just see if I can zoom in somewhere where it's actually going to start doing something. No, I better not actually. It's very, as I say, I have a very slow map or slow internet connection. So if you have a slow internet connection, this function is very useful. I shall go back to OpenStreetMap Topo before it starts to refresh. To get into that function, to prefetch your maps, there's a button down here called Map Options. You click on that. There's a function called Map Quad. And that allows you to pick up your map levels, 7 to 19 in this case. Now, the map level is the layer or the mapping layer that's being displayed. It's not the zoom level, but it's the map layer. So each set of tiles is displayed on here. This is actually currently layer 13, because down here in the bottom right-hand corner, I hope you can actually see that, it says L13. That L13 means that this is map layer 13. Now, the thing about this is, don't get enthusiastic, because this is taking layers 7 to 19, which is, so it's going from that greeny stuff there, that layer, all the way down to about that. For a relatively small area, it's probably only about 40 kilometers square, something like that. That on my network connection took more than 24 hours to download, because it doesn't just download the little bits that you need. If I wanted to zoom into here, for instance, to Carridon Hill, which is the transmitter site I was working on for this project, this area here, if you just zoom in it normally with download mapping, it will just download the squares for that and you'll be fine. And when you zoom back out again, you just get the layers that you need. With this, it downloads everything, all the way down to zooming in on every little piece of that map. That's a hell of a lot of data. So don't do it for the whole of your country or for the whole of Europe. Your Bing Maps license will run out. It is actually limited. There's a crazy number of tiles you can download on your API key, but if you exceed it, you're stuck to the end of the month. It's like a mobile phone data limit. And doing this for the whole of, let's say, the whole of the UK would probably hit that limit before you got there, and it would probably take a very long time. So yeah, use it with care. Use it for small projects where you need to download the data or the map data, and you just want it to be quite quick like that. And if you can, get your IT people to set you up with a cache or a map cache or a caching server, something like Squid or something like that, which will download and cache all these tiles on its own hard drive for you for when you need them. And then you and your colleagues can both share the download if you're working on the same area. Otherwise, it just comes to your computer. So everyone has to do this. Right, that's that. I'm going to move on quickly. North variation. This is causing it does cause some consternation with people that expect north to be at the top of the screen and not slightly one side or the other. In the UK, using the EPSG European Standard Prediction Mapping, which is what we have. If we go back here, you can see all these. Let's go. Actually, if I go to Bing Roads, that uses UK Ordnance Survey mapping as for one layer. You can see all these lines. These are Ordnance Survey North, Grid North, and it's all canted off towards the left slightly. That does cause consternation to some people that believe North is actually National Grid North rather than European North. So this uses the standard European North. You have to be a little bit careful about that. For instance, these, if I go here, object, if I display the azimuth on these things and make them standard size, we might actually be able to see them. These are theoretically facing north, due north. You can see the little arrow on top is pointing to the top of the screen. So you have to change your north variation to make sure that you've ticked dynamic declination. If you do that, then it dynamically points them north according to how your mapping and how your grid system should work. So instead of pointing north, instead of using north as the top of the screen, it's actually using north following the grid that it should be. So if you want microwave links and bearings and everything to look right, make sure in preferences the north variation is set to dynamic, and then it adapts itself to the mapping and the background terrain. What it won't do is it won't make this map fit the square, so you'll still have a sloping map using the European standard mapping layout. So you just have to be mentally agile enough to be able to understand that north is not the top of the screen, but it's slightly canted to one side. And if you work in one country for long enough, you tend to get used to it. But I do know people certainly on the far east and the far west of Europe, like in the UK, it is quite noticeable. In other parts of Europe, it isn't such a noticeable variation. But that's something worth considering. We are planning on producing more localized north maps, but it's only really for countries where it's a real problem. Elsewhere, not yet at the moment, unless you're willing to get our cartographics people to do it for you. Right, that covers that side of things. If I just quickly whip back up here to the agenda, what we'll do now is, if that's okay with you, Sarah, we'll just go straight on to doing the drive test data. She's gone to sleep. Okay, we'll carry on doing drive test data, import and display. What I'll do first is I shall bring in a picture of this is the ARES radio planning or performance monitoring tool. What it is that this is a plot of the signal level received by a mobile phone, actually in my car, and what the mobile phone is doing is it's just recording signal level and also whether or not it's got a signal or not. The grey means it has no signal, and it also records. And this is for a UK mobile phone network that apparently isn't very good in the area that I live, by the look of that. If we look here in the configuration, most of it is below neg 97 dBm on my test phone that I had in the car, and it was actually on the back parcel shelf of the car, so it's not as if it was in the footwell or anything like that. And neg 97 is edge of service. Anything lower than that is actually out of service. You get a signal, you can talk, but it is officially out of the base station service area. And in fact, it only went into service just here. Now, what this also produces tabular data of signal levels. So there's the phone, its lat and long, how high above the ground it is, how fast you were traveling, what was happening. This is no service is quite common in my part of the UK. What kind of service the base station should be supplying you, and over here somewhere there's the signal level as well, the receive level. Now, all telecom requires is your lat, your long, and a signal level. ARES itself will produce all sorts of other useful data. You can say, for instance, here it will tell you, for instance, how many for the data I've got. This gives you an idea of the amount of the various types of mobile phone network that I was actually operating on while I was driving about. Gives you details on percentage types of levels and that sort of thing. Essentially, it's not exactly the best trip. This is actually very high as well, and there's virtually no mobile phone coverage from this particular network, which is sort of surprising. Anyway, what we're going to do is we're going to take this tabular data and convert it into something that can be used for telecom. There are two ways of doing it. You can either export this whole data pack, and if you were downloading it for later analysis, you'd probably do that, and you just click on export data here, for file name, and export it. It will just export the signal strength data, and we'll do that. I'll just save that. I'm not absolutely sure where it will be. Okay, we'll open that. When it gets there. Yep. And that's what you get. Longitude, latitude, and signal level. I know it should be lat long and signal level, but that doesn't matter too much. Not with telecom. So that's what you get. You get a nice short 500 piece or thereabouts data file with position and signal level. If you were doing large quantities of this, you probably wouldn't be able to manipulate it with a spreadsheet. You'd probably have to use a text editing tool or something like that, command line tool. Oh, I need to turn that off. I'm going to need to have that available for telecom. So what I'll do is go into telecom and let's import it. Now, it's not desperately obvious where this function is. It took me a little while to work out where it is. What you do is you go to Measure, Import Drive Tests, and then there are drive test generic format, X, Y, and E. And if we, I shall just download. Oh, it's not the same one, but it's the same path. And that says longitude, latitude, signal level, which is actually right for the file. I think that actually picks that up from the file itself. If it didn't have column headings that it could interpret as well-known data types to identify which column does which, and you just had long lat and signal level in unnamed columns, click on that and it will invert it into lat long if you need to. It all depends on whether you want this stuff to end up in the right place or not. Coordinate code is WGS84 decimal format. Threshold, we'll set it for 10. The conversion value from dBm to dB microvolts per meter, I'm just going to guess it. It's about right. It's we're for what we're doing, 134 is probably about right. Everything else should be okay. Click OK, and with any luck, it'll turn up, unless I've done something very wrong, which is quite likely. The way my brain works. Nope, here we go. Oh, I know what we need to do. We just want to get rid of this map layer and go back to something more sensible. So there's my little drive test. And again, it will work quite happily with the palette that's been recorded. Though the levels here are not, so it picks up your local palette and displays it. And in fact, there's a little bit of green that was in areas. It's brown on this particular palette, and basically anything that's yellow or red is where it's completely out of service. But anyway, that's your drive test data. And what you would do is large quantities of drive test data will tell you more, or give you more information over the actual performance of the equipment being used on the network that you're planning. And you can use that to, it's not so much tune the model you're using, but tune the way your network is being displayed or designed to to give coverage to representative pieces of equipment in representative ways, rather than just assuming that it's a perfect quarter wave 1.2 meters off the ground or something like that. So that would be quite useful for model tuning. Within Aries itself, if we go back to Aries, on this map, it can't do it on this one, but if you zoom out a bit, there's a little bit of correlation going on. We have here the mobile phone base locations, and there's another one just up here. Oh, there we are. There. That's the one that should be running. I don't think it's up. I think that one's dead. That's the one that would cover this area with 2G quite comfortably. Now, what Aries allows you to do is, if let's say you're driving along here, and just around here you get a really, really strong signal, it's able to identify roughly the location of that particular site. Knowing that there's a new site there that isn't actually in your database, you can actually then just display or filter it to just display that particular or signals from that particular site. That gives you a very good idea of where that site is, in fact, and gives you site, all the site information that it would produce. For instance, here, the LAC and the site ID and cell ID and what type it is, and there'll be an operator ID on it. That sort of information will come out of the drive test data, so it's quite useful in that respect. And there are lots of other things you can do with this tool for analysis, over and above what we would be doing in telecom, which is more to do with the actual tuning of your model afterwards. This allows you to analyze the data that you've received, and it does it in real time, so you can send some people out taking measurements, and you can actually watch the measurements come in, and even direct them to drive to places that you might need more or might have some interest in, so they can get measurements. So it can all be done live, rather than just going out, collecting it all, and then looking at it and then realizing that it would have been better if you'd done things slightly differently. So that's all very, very useful, and that's how you would import drive test data. So quite simple. Let's just get back into telecom. All you need is measure, import drive test, and generic format, but just make sure that you have a conversion value set. You click on converter, you can set the frequencies and various levels for the different type of system. It's a mobile phone. It's going to have an antenna gain of probably minus 20 dB or something like that, what they euphemistically refer to as an implementation loss. But I'm assuming that it's a nice one, and that's
hang on. I will interject here.
Go on, interject.
I will interject. This data being gathered by the Aries system is not gathered to something called the Lee criteria, which is a statistical method of making sure that you are actually measuring the correct level. So this really shouldn't be used for propagation model fine-tuning.
No, that's what I did say that.
Sorry, yeah. In that case, I'll shut up.
Oh no, you're right. A lot of people think that drive testing should be used primarily for model tuning, but the model is good enough, thank you very much. What you're doing here is you're actually testing the network's performance on a representative piece of equipment, probably in somebody's pocket while he's driving. So what you're doing really is actually tuning your network coverage as predicted to give some idea of what the actual performance is with particular types of equipment, which gives you a rough idea of, and it is relatively rough because I could drive test that again today and it might be completely different. The weather will be different. The actual position in the car might be slightly different. Might be raining. So you shouldn't really tune your models too carefully with this sort of data. And as you say, the criteria is basically it measures what the phone measures and records it. That about right, Nick?
Yep, that's right.
Good. At least I understood something. That's the first thing I've understood in the whole thing so far. Anyway, well, what we'll do is we'll go back here. I'll do something I do know a little bit about, which is shapefiles. Only a little bit, but needless to say, this will probably also cause all sorts of ructions when I try and make this work properly. So what we'll do is we'll go back into dear old Telecom. I'll just display the map player, zoom out a bit, and zoom back in again on this site that I have prepared earlier. This is if any of you have ever come on holiday down here to the southwest, it's a popular holiday destination, which is the reason I live here, for the weather and the food. I've just plonked a base station in the middle of the stannery town of Liskeard, and what we're going to do is we'll just quickly calculate a coverage for it. Just make sure I've actually got a model on it. One of the other things about the newer things about Telecom is by default no propagation method down here is selected. It's not an error. It's not a bug. It's who knows who's using Telecom. If it defaulted to 525, you can bet your bottom dollar that somebody who does line of sight coordinations for aeronautical work will complain that it always goes to 525 and why can't it go here. So what they've done is nothing is on here. So you just have to be careful when you're doing a calculation for the first time in project to make sure you've got the settings for your prediction model correct and actually set. Otherwise it'll just do line of sight. I'm using 525.526 version 14 with Delta Bullington. It's faster than 1812. Not necessarily more accurate, but it's faster for this. That's what I'm going to use. I forgot to check the clutter. Yep, all the clutter's about right. Those default levels. Doesn't really make any difference. We're not going to be using this for anything other than a demo. So right, there's your coverage. What we're going to do is it's a circular coverage area. That is deliberate, Nick. What we're going to do is now export that coverage layer as a shapefile. Now, as you can see, the coverage is quite detailed, and usually a GIS bod probably doesn't need that level of detail. It depends really how you want to do this. You might have to play with these filters depending on the size of the file you're going to produce and everything else. But that sort of averages out these things and makes them a little bit more blocky and fits the kind of contours that GIS would like. Sampling is usually set to 2. It doesn't make a lot of difference here. It's quite a small map, and you save it as an area. So you save it as a shapefile. I've already saved it, but I shall save it again on top of itself. There we go, and it's done. Now you go into your GIS tool of choice, which in my case is QGIS, because I'm poor. Layer, add layer, and you add a vector layer. The thing about QGIS is it'll work out what kind of vector layer it is. There's no need to actually tell it. You just have to tell it where it is. So it's a shapefile, and that's what you get. Let's just zoom out a bit and let it re-render. And that's what you get, which actually for some automated analysis is about all you need. But if you actually want to make that look a little bit more human readable, you need to change the colors and do a bit of manipulation. Now, one of the things you need to be able to do in order to be able to work out what is to know what is what. If you go back into telecom here under user palette, this is one of the big gotchas. See these labels here? A lot of people don't label their palettes. This is just a rough mobile radio palette, but if you don't label those, these labels are the labels that the various entities in the shapefile get, and it's very important to label them with something that you'll know. I'll show you that in a minute. So we go into this shapefile and open up its properties. Lots of properties, but the one you want actually opens automatically. And it's the style of this thing, and we want it to be rule-based, and it has to be rule-based based on the levels or the entities within it. So you click on that, and the first thing you want to do is to get rid of this horrible purple color. So what you do is you change the color to white, and then you also change the transparency. In a minute, there's a dialog box that's popped up on another screen, so that's why you're not seeing it. Make it entirely transparent. Click OK, click Apply. It's now entirely disappeared. Next thing to do is click on the refine the selected rule. That is a rule with no filter. We want to add categories to it. And you just click classify, and that just picks up, here we are, your legend and your values. It's always a good idea to have all these things, because you're going to need to now sort them, because they're not in any order, because a shapefile has no order of entities. There's no hierarchical there's no hierarchical pattern of entities within a shapefile. It's just a file full of shapes with names. So you need to move this all about. Dare I do this? We'll start at the bottom, not interference. That's right at the very bottom usually. Then you get incoming interference. Oh, come here. No, we're doing incoming interference, exported interference. I'm not sure which is which now on this one. I'll do that. You can either supply them with random colors or some kind of spectral thing. Blue is probably better, and we shall invert that so that the stronger the signal, the darker blue it is. Click OK, and then we get rid of that one we don't want and that one we don't want, which are extra entities that didn't actually get a name in them in the palette. You click Apply, and click OK as well. So there is what your GIS person will see. That's your coverage contours for this random site in the middle of list card while this thing renders. Obviously you can't see list card, so one of the other things you need to do is to go back into properties. You should have done this beforehand really, I suppose. Give it a 50% transparency, and you can now see what's going on. You can also open this up and you can remove layers. So for instance, for the site itself, handheld coverage, handheld or radio of this sort will have a very poor antenna, probably with an efficiency of -60 dB, something like that on what you'd expect. So -8 dBi, something like that would be acceptable for a handheld with a rubber ducky antenna. That just allows you to see the handheld coverage, and you can add the other coverage layers, and your edge of service and usable are swapped around. So you can analyze them, and it's not really for visual analysis. What you're actually going to be doing is your GIS people will be analyzing addresses and percentage of population covered and that sort of stuff. But that's the kind of thing that they will be expecting to see. It doesn't look like a radio coverage anymore, and it isn't. It's a statistical, or it's a layer in a statistical analysis tool, or in an analysis tool. So that's that. What I'm going to do is I'll put together some notes on this, because it was actually not that easy to find some easy notes on how to how to categorize shapefiles like that for QGIS, let alone for other tools. But hopefully that's given you some help. But I'll be producing some handouts for that at some point or another. And
okay.
As far as I can see, we've run out of time. I'll go back to the end here.
Before we finish for today's event, it'd be a great idea if anyone's got any questions to put to Simon. You could use the hands up. I can unmute you, or you can put a question in the questions toolbar. So if there's any questions following up from the subjects we've just covered, or if you'd like to raise any other questions, please do. Okay, while we're waiting for those questions to come in, and please do feel free, we have got time, we'll hang on and take those questions. There is a recording from today's event, and that will be distributed to you later today.